comes to this oxidation of alkene. Now, please remember, okay, you can oxidize alkene. Okay, you can oxidize alkene using two ways. You can use potassium manganate 7 acidified, okay, under hot and cold. But do remember, potassium manganate is the same as potassium dichromate. Even in your book, okay, they didn't mention, even in the syllabus, they didn't mention. But if they have potassium dichromate over there being an oxidizing agent, it will function the same way as potassium manganate. So what you need to know about potassium manganate and potassium dichromate is going to be the color change, the possible color change. Okay, so you need to know that. So maybe let me check. Okay, Jackson, can you tell me what is going to be the color change if there is a positive reaction with potassium manganate, Jackson?
Is it like blue to purple or something?
It is purple to colorless. Okay, purple to colorless. Potassium manganate. Okay, please remember also. Okay, potassium manganate, if it is in solid, it looks like a black solid. I think one of the popular question when last time in science or something like that, they say they want to test for diffusion. Okay, diffusion in solid. Okay, the best way to test is having a gel, okay, and then you put a small amount of potassium manganate. Potassium manganate is purple in color, okay, it's actually black solid, okay. So when you put there and you put the gel, okay, after a few days, okay, the gel will start to become purple. So it shows the diffusion is happening in solid. Okay, so that is a common example last time. Okay, but now in chemistry, in AS, and what you need to know is the color. Okay, the original color, okay, is going to be purple. So when there is a reaction, okay, the purple color will change into colorless. Very important, must know. Okay, must know. And in redox, okay, we have learned that purple color is given by MnO4 minus ion. And the colorless ion that is in charge is Mn2 plus. And you need to know, okay, how do I write down the equations for that, the half equation for that? Okay, since it's our class only, I can just proceed with this. Okay, you see the equation involved Mn, okay, O4 minus, okay, and it's going to become Mn2 plus. Okay, so if I want to balance this, you see there is no there is oxygen here, okay, but there is no oxygen. It must be in form of water, okay, on the right hand side. And if I introduce water, okay, on my left hand side, I must have H plus. That's why it must be acidified. Okay, without acid, the reaction will not happen. Okay, so there must be H plus. Left with balancing. Okay, so balancing is quite simple. Okay, if you have O4, okay, so of course you want 4 here. Okay, so if I have 4H, so I need to put 4 times 2, 8. So I need to put 8 over there. The last thing that you need to do is to balance the charge. Left and right must be the same charge. You see 0 charge here, plus 2 here. Overall charge is plus 2. Okay, 8 plus, okay, and then negative 1. Overall charge is going to be plus 7, plus 8 minus 1, yeah, plus 7. So how do I make the charges the same? Okay, the only way that you balance the charge is by adding electron. Okay, so electron is negative 1 charge. So I need to add, okay, 5 electron. Okay, when I add 5 electron, it means it's going to be minus 5. You will get plus 2. Plus 2 and plus 2 is balanced. So this is the half equation. Okay, so I'm just teaching you about redox also. Okay, please take note. Okay, so now coming back to this, okay, the color change is very important. If I'm using K2Cr2O7, okay, Audrey, can you help us out over here? What is the possible color change if positive?
Green to orange.
the other way around, actually. Yeah. The other way around. I think the color you need to remember, okay, it must be orange, green, orange, up to you. Okay, but how do I remember? Also, I just remember this way. Sometimes I don't have the problem. I switch it, okay, because I always think that green is a better color than orange. Okay, why green? You see, everywhere is green. Okay, grasses are green. Okay, nature is green. So I want something that is being positive. Always I want to form green. Okay, you can remember that way. So orange, okay, orange to become green. So I hope, okay, there won't be this problem. You mix, okay, orange to green or green to orange. Always remember, you want to see nature. You want to see something that is nice looking. Okay, so it's always orange to green. Yeah. So there is no other situation where we will deal with green. Okay, but yes, later on when we look into this transition metals, okay, in your A2, yeah, we will have these green ions, okay, and so on. So complex, okay, so that one we worry about it later. For now, very important, must know the color changes. Yeah. Now come back to this oxidation of alkene. Okay, so if you are using cold and dilute, okay, when they mean cold means not necessarily must be 15 degrees Celsius or negative 15 degrees Celsius and so on. They just, in your syllabus, they just want cold means it's going to be room temperature. Okay, so if it is room temperature and I use dilute, okay, what will happen? And another one is going to be something that is much more harsh condition, okay, which is going to be if I'm using hot, okay, they didn't also mention that it's going to be how hot is it, 100 degrees and so on. You no need to know the temperature, okay, but it must be concentrated. Okay, I forgot to put over there, it must be acidified also. Without the acid, the reaction will not take place, you see. Okay, without the acid, the reaction will not take place. Of course, you can do the same thing. Okay, just now orange to green, what is going to be the color change and so on. So this one is going to be Cr2O7 2 minus, they will become Cr3 plus. The green is coming from Cr3 plus. Okay, and how to use the equation and so on. Okay, please learn it yourself. Even if you want me to show it to you now also, okay, I think no harm in showing now also, no problem. Cr2O7 2 minus, and you are going to become Cr3 plus. Okay, so first balance this 2, so I put 2 there. There's oxygen on my left hand side, there's no oxygen on my right hand side, I put water. Now there is no H on my left hand side, so I just put H plus. Okay, and then I try to balance. Okay, the oxygen, there's 7, so I put 7 here. Okay, the moment I put 7 there, hydrogen is getting 14. Okay, so I just put 14 there. The last thing is to balance the charges. Okay, the charges is 0. 2 times 3 is going to be plus 6, so the charges is plus 6. And then this is plus 14. Okay, this is negative 2. Okay, when I add, it's going to be 12. So now the only way to make the charges left and right the same is by adding electrons. So I add 6 electron. So when I add 6 electrons, minus 6, I'm going to get plus 6 and plus 6. Okay, so this is how you balance the equation. Yeah, so please learn how to do that. Okay, so now, okay, if we have all this, okay, so why I did this is to show you again, you need, okay, you need acid. Okay, you need the acid. Now coming back, okay, what will happen under dilute condition? Very easy to remember. Okay, if I have an alkene, okay, under dilute condition, what will happen? Okay, the H, okay, the double bond, okay, the double bond is going to be broken, and you are going to get OH here, OH here. This is called diol. Okay, OH and OH, diol. Okay, so how this one is going to be formed? Okay, you need to know also. Okay, but okay, you need to know in terms of writing equation, but this is not so important. Okay, not so important. Okay, but if they ask you to write the equation, it will be something like this. Okay, plus, okay, this is going to be the oxidation. Okay, anytime when we have oxidation, we put like that, and then you put H2O there. Okay, because of dilute. And what will happen? The OH will come here, and then the another H with this will join there. You will get COH, OH. So how you want to write the equation and so on? Yeah, you can use this as an example. You can base on this, okay, and then try to write it down. Okay, that is very simple. Okay, when it comes to oxidation of alkene under dilute condition. Yeah. So let's focus on the hot condition, okay, hot concentrated. What will happen? This one, maybe some of you will have problems because, okay, maybe difficult to understand and so on. So this one, okay, we need to focus more, okay, because, okay, we will have different situations, okay. So let us look into 3 situations, okay. And every single time, maybe I'll just give you something, maybe H over here. Okay, so this is going to be ethene. And when I do oxidation of ethene under hot condition, what you need to do, just separate this part first. Okay, and the moment that you see, okay, carbon attached to hydrogen and hydrogen, okay, you will form carbon dioxide and water. No need to know the equation, not required in your syllabus. Okay. On my left hand side, automatically also the same carbon dioxide and water. So that's the first situation. Okay, that's the first situation. Second situation, okay, if I have, okay, this one is going to be CH3 and then I have H over there. So maybe here I put H, I put CH3, something like a trans isomer. Yeah. Now, what will happen? Again, the same. Okay, you break. The moment you have CH3, that is C2H5 and so on, we count it as R. Okay, so this one is 1R group. Okay, so whenever you have 1R group, okay, and 1H, okay, what you need to do is, okay, the right hand side is you do like normal. You put the O here. Okay, you put the O there, and then keep the R, which is going to be CH3. Okay, keep the H. Okay, but it doesn't last forever. Okay, it doesn't last forever. This one is 1R. If I just put it over here, if I rewrite this, okay, it's CH3 and then H. This one you should know is an aldehyde. Okay, it's an aldehyde. So this aldehyde, they don't stay, okay, because it's harsh condition. Further oxidation will take place. What will happen? Okay, further oxidation, the another O will come in over there. Okay, another O will come in, forming, okay, so I'm just skipping that part, forming what we call as, okay, this one is carboxylic acid. You can see CH3, C double bond O, OH, carboxylic acid. Okay, so it means that if you have 1R group and 1H, they will form a carboxylic acid. The same thing, okay, will apply when you look at the left hand side. Okay, 1R group, okay, 1R group. So first you do this, okay, you put the H, CH3, further oxidation, okay, then you will have OH then. Okay, same. And then, okay, left with the last one, okay, last situation. Let's say I have CH3 here, I have CH3 here, I have C2H5 here, and I have C2H5 here. The way to do this, okay, separate them, okay, but this one you see 1R group, another R group. This is another R group, another R group. So if you have 2R groups, okay, you are going to have, very simple also, okay, just put the CH3 over there, just put the O. Ketone cannot be further oxidized, okay. Aldehyde can be further oxidized. I think last time you remember, yeah, for a primary alcohol, they will be oxidized to become aldehyde. Aldehyde will be further oxidized to become carboxylic acid, the same concept. Yeah. So here, okay, ketone cannot be oxidized. The same thing on my left hand side, C2H5, okay, and then C2H5. This one is going to be O. So this is going to be ketone. You are going to get ketone. So if you have, okay, situations like, for example, if I have C double bond like this, and I have CH3, and I have C2H5, and I have CH3, and they say I am going to oxidize this using hot concentrated potassium manganate. Okay, what is the product that, what are the products that I will get? There are going to be multiple products. What are the products that I'm going to get? In order to do that, you separate this first, left and right. Or you have this H1R group. So first you are going to get CH3H. Okay, after that, you know, it's a carboxylic acid is going to be formed. Just need to put another O. Yeah. So this is going to be produced at my right hand side. On my left hand side, okay, I am going to have two R groups. So I'm going to get C double bond O. Okay, just put the double bond O there. C2H5 and then CH3. So I am going to get ketone. So by now, you should be able to identify. Okay, the summary is over here. Okay, so if I put it as a short note, okay, if I have double bond H and H, I am going to get carbon dioxide and water. If I have double bond C, 1H, 1R, okay, I am going to get C, 1H, 1R, but after that, they are going to be further oxidized to become carboxylic acid. And then if I have a situation where I have double bond C, R, and R, I am going to get this, okay, and then R and R, keto, okay. So this one, is for short notes, okay, this is going to be the one that we will focus on. Okay, so this is going to be something that you need to remember. Now for addition polymerization, I already explained to you. So probably now for the 15 minutes, I'll just discuss some questions with you. Yeah. So here, okay, which statement about polyalkene are correct? Okay. So polyalkene, okay, because okay, if you have this alkene, okay, so what will happen? Okay, the double bond is broken, so you are going to have H, for example, and then you are going to have this as a polymer. Yeah. So if it is like this, okay, the alkene polymer, okay, they do not have any unsaturated bond. Okay, there is no double bond. So they do not react with Br2 in the dark is correct, because okay, they will behave as though like they are alkane. Alkane will only react with Br2 under the presence of UV light or sunlight. So they do not react in the dark. So that is what they mean. Yeah. And then disposal by combustion can produce harmful products. Yes, correct. Okay. One of the reasons that we don't burn polyalkene, okay, like PVC. PVC is an example of polyalkene. When you burn them, okay, they do give you harmful and toxic gas. Okay, so we don't burn PVC. And then polyalkenes, okay, do not easily biodegrade. Yeah, because the presence of single bond, okay, they are saturated. Saturated means cannot add any bonds. No bonds can be broken. So what happens is they are not readily biodegrade. They are unreactive. Yeah. So therefore, the answer is going to be 1, 2, 3. This one, okay, the next question, I think I went through this in the class, okay. They say that they put the CH3 here, okay, one of the isomer, okay, but okay, where the CH3 can come, yeah. So you see, if I put the CH3 over here, this is going to be another isomer, okay, position isomer. If I put the CH3 here, another isomer, I can put the CH3 here, another isomer, okay, but I cannot put it here. Why? Because all the 4 bonds are taken, 1, 2, 3, 4, okay. So when I put the CH3 means it's going to be a some sort of substitution. I'm substituting the hydrogen. Okay, so I cannot put it at that place, but I have one hydrogen here. I can substitute that with CH3 here. So how many places that I can substitute to give you a different product, different isomer? So I have 1, 2, 3, 4, 5. Okay, so that's why the answer is 5. And then the number of pi electrons each, okay, each pi bonding, okay, it's if you remember what I said, hybridize, okay, they will actually hybridize and then form the sigma and so on. The pi bonding always involves unhybridized orbital, okay, the one PZ and so on, unhybridized orbital. And when they have unhybridized orbital, okay, that unhybridized orbital is there because they have one electron. Okay, so one hybridized orbital with another unhybridized orbital where they form this sideways overlap. What happens? One electron here, one electron over there. Each of them will have two electrons. Okay, so it means each pi bond here will have two electrons. Each pi bond over here will have two electrons. That's the reason why you have total number of pi electrons. The answer is going to be 4. Okay, I hope this one is clear. Okay, if they ask about number of pi electrons, very common question when they ask what is the number of pi bonding. Okay, but this particular year they ask the number of pi electrons, and you can see they are testing on that part. Even they give you the 2 over there just for you to make mistakes. Okay, so that 2 will be valid if they say the number of pi bonding. Okay, but when they ask number of pi electrons, you need to times by 2. Now here, okay, I will skip this part. Okay, which compound has molecular formula C6H10? You count. Yeah. The only thing that you need to be careful, each end over here is carbon. Okay, so do remember there's always going to be 3 branches. Okay, for hydrogen. Okay, we don't show carbon, we don't show hydrogen. So if you count that, okay, you need to do one by one. Okay, and you will get the answer. Okay, the answer is given. Okay, it's A. Now, so this one, okay, which compound is chiral? Okay, I think I'll show you. Okay, the answer is going to be C. Okay, I will show you C. Maybe I select one, maybe A. I'll compare. Okay, let's see. Okay, so if let's say I draw for 1-chloro-3-methyl-butane, always remember we always start when we draw, we look at the towards the end. Butane, so you draw butane for carbon, and then 3-methyl. 1, 2, 3, 3-methyl. 1-chloro, you put the Cl over there. Now, the rest are all hydrogen. Now I need to, okay, now I need to find out which of these carbon has chiral center. Okay, and do remember chiral center, all of the groups must be different. You see here, this is not chiral center. Why? 3 hydrogen. 3 hydrogen, not chiral center. Okay, this is not a chiral center. Why? If you look at the right, this entire thing is going to be CH3. This is entire thing is going to be CH3. Cannot. If I look at this, okay, I ignore this. Why? Hydrogen here, cannot. So left with this, okay, this one also cannot, hydrogen here. This is also not a chiral center. So you need to analyze, okay. So this one cannot be, okay, something that is optically active, cannot, yeah. But when you look at 2-chloro-3-methyl-butane, same the way we draw C, 3-methyl, okay, and then 2-chloro, if I put 2-chloro over there. Now I try to identify whether they have chiral center or not. Okay, automatically when I see this, I have 3 hydrogen, not. Okay, 3 hydrogen, no, cannot be. Okay, this one cannot be, CH3 and CH3. So left with only one here. I know this is hydrogen, a different group. I know this is CH3, a different group. Cl is a different group. CCH3, CH3 is a different group. Okay, so because of that, this is a chiral center, and that is the reason why we selected C as our answer. Okay, you do the same thing for B and D. Yeah, so this one you have to do it one by one. Okay, but in exam you have to do it very fast. Yeah. Now, compound X, okay, does not show cis and trans isomer. Okay, what will be the identity of compound X? Okay, so we want to find out. Okay, so you have to do it one by one also. So when you do this, okay, always follow the last one, propene. Okay, propene. So double bond, okay, doesn't matter where you put the double bond, it's still propene. Okay, and then this is 1, 2, 3. So 1, 1, 2. 1, 1, 2 trichloro. So Cl. Cl, Cl. So I want to find out, okay, whether this one show cis and trans. The carbon, okay, is attached to two same groups. Cannot. Okay. Automatically, the carbon beside the double bond must be two different groups. Okay, so automatically one, no need to even see here. One is out. Okay, something like that. The answer is going to be does not. Okay, that is the answer. Okay, but let's see. Maybe we check with D. Okay, let's see. So if it is going to be one chloro boot two in, so I draw boot two in. Okay, position number one, position number two. Okay. If that is position number one, position number two, automatically this is carbon number one, carbon number two. Okay, automatically. So one chloro, okay, one chloro Cl is here. So I want to know, okay, whether this one shows cis and trans or not. So you just look at the carbon, okay, beside the double bond. So there is hydrogen. This is CH3. There is hydrogen. Okay, there's going to be hydrogen, hydrogen. So you can see one different group, one different group, and this is a different group. So can. Okay, so that is how you identify. Okay, so you will find out that this one also can, this one also can. So only one that cannot, okay, is going to be A. Yeah. Now, if you go further, the diagram shows a repeat unit of an addition polymer. Okay, this one's quite simple. Bring in, okay, the double bond there. So it means now you will have C11C. Okay, you will have CH3 here, C2H5 here, C2H5 here, and CH3 here. And then if you are looking into like naming, okay, please always name according to the longest carbon chain. Okay, if you name according this one, 1, 2, 3, 4, this is only 4 carbon butene. Yeah. So if you name here 1, 2, 3, 4, 5, 6, it's supposed to be hex. Okay. If you just follow that, okay, automatically that is going to be the answer. Okay. But if you want to further, okay, if you want to really want to name it, okay, this is going to be the longest carbon chain. So this is P2, so number one, number two, okay. And then this one is going to be gap number one. So gap number two, gap number three, okay. So this one is going to be, that's why it's hex 3 in. And when you name that carbon, okay, you know that this is carbon number one, carbon number two, carbon number three, carbon number four. Okay, so the methyl group is at carbon number 3 and carbon number 4. Okay, that's the reason it's going to be 3, 4. And then why dimethyl and why is trans? You can see itself, it's opposite. Okay, CH3 and CH3, they are opposite. That's the reason why it is called trans. So that's going to be the answer. Okay, that is how you identify. Yeah. So if I move further, okay, here, okay, the product of the reaction, okay, does not show stereoisomer. However, boot one in, okay, reacts with HCl. So let's actually draw boot one in. Okay, this is going to be boot one in. And then they react, okay, just ignore the first part, okay, doesn't matter, okay. However, boot one in react with HCl. So when it reacts with HCl, okay, what you need to know, there are two possibilities, okay. One is you will have the double bond broken, okay. So the double bond is going to be broken, and you will have a situation where H come here, Cl will go there, or Cl come here, H go there. Okay, but you need to know, okay, the concept rich becomes richer. Yeah, I told you about this. So here, if I have hydrogen here, I have hydrogen here, I have hydrogen here. The carbon that has the most hydrogen is this one. So the hydrogen, okay, they will go to this carbon. So this is going to be the major product. This is the minor product. But the reason you need to know, okay, the reason is because the H goes there, okay, you are going to get a carbocation, which is going to be a plus over there. If I put the H here, plus over there. So you need to identify what kind of carbocation you are forming. This is one R group, one R group. Okay, so this is a secondary carbocation. If you look at this carbocation, one H, okay, another H, one R group. So this is primary carbocation. So secondary carbocation is more stable compared to primary carbocation, and tertiary carbocation is more stable than secondary carbocation. That's the actual reason, okay, behind the concept rich becomes richer. It will help you, okay, but if they ask you to explain, okay, the carbocation, okay, is going to be, and then the term that we use is going to be the R groups. Okay, the R groups will give you a positive inductive effect. Okay, go and read or go through the videos that I've shared to you. So it will give you the positive inductive effect that will stabilize. Okay, that will stabilize the ion. Okay, so it means that's the reason why secondary carbocation is more stable compared to primary carbocation. So they are going to be formed, okay, better, or will be more formed compared to this primary carbocation. Yeah. So to answer that, you see, I explained the meaning of a stereoisomer. Yeah, same different molecules with same molecular formula. Okay, with different arrangement in space. Okay, but what I want you to focus is going to be the atom. Yeah, so this is the reason why we do past year papers. Okay, to identify, okay, what they want in your exam. Okay, in your exam they want you, okay, to mention different arrangement of space in space. What arrangement? Atom. So that's the reason why they have highlighted that. So next time when you answer, make sure you include atoms, different arrangement of atoms, okay, in space. Okay, give two reasons why boot one in does not show stereoisomer. Stereoisomer, there are two. Okay, one is going to be cis and trans. Second is going to be optical isomer. So that's the reason why they have 2 marks. Okay, the first one, okay, because the carbon attached to the double bond has 2 same groups, cannot have cis and trans. So that will be your mark number 1. Second is you identify whether they have any chiral center. The moment that they have double bond, don't have chiral center, don't have chiral center, because they need 4 bonds. Yeah. So here, okay, if I have H and H, no chiral center as well. Okay, I have 3H, no chiral center, because I need different groups. Okay, so that's another answer. Okay, they do not have any chiral carbon, then you will have the answer over there. And then this one, okay, they have identical group. Okay, you answer that. Name X and Y. Okay, so they say that X is higher yield. So this is major. So this is X, this is Y. So how do I name X? Okay, so this is butane. Okay, at carbon number 1, carbon number 2, that's chloro. So it's supposed to be 2-chlorobutane. And then this is carbon number 1, 1-chlorobutane. What type of stereoisomer? Okay, so the type of stereoisomer that they show, okay, they say that it exists as a pair of stereoisomer. Okay, so what kind of stereoisomer that it's going to be existing in X? Okay, you need to identify. There is no double bond automatically, no cis and trans. Okay, so you identify which one is going to be the chiral center. So I see hydrogen, 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 no chiral center. Hydrogen, 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 no chiral center there. Hydrogen, hydrogen, no chiral center over here. So Cl, okay, CH3, H, and this thing is different. Okay, so this is the chiral center that we talk about. So here, this is going to be optical isomer. Use conventional representation to draw. Okay, so if we just use this, how do we draw? Chiral center start first. Okay, at the top is hydrogen. Okay, and then the same. Okay, we just put lines, 2 lines. Okay, then you can write CH3. This one you put like this. Okay, this is going to be Cl, and you put dotted line showing that they are behind. So this one is C2H5. Okay, you can write down C2H5. So if I select this, okay, and I want to bring it down, and then I want to show, okay, that I want to show that this is going to be a mirror image, okay, because you need to show that. So you draw, okay, you say that this is C, okay, H, and then this one, okay, dotted line C2H5, okay, and then this one come over here Cl, and then this one just replicate, okay, mirror image, and I get CH3. So this is going to be the optical isomer. Yeah, so that's it. Okay, then I want to explain to you, but maybe, yeah, okay, I'll take another 2 minutes. Okay, guys, remember the part that I told you about this CH4, okay, or any kind of alkane, and I have C2H like this, okay, identify the type of hybridization. Yeah, the moment that you have 1, 2, 3, 4 bonding for each carbon, you should remember there should be 4 orbitals involved. Okay, so simple way is to say sp3 hybridized. Okay, you need to know by heart because most of the time they will ask you in your MCQ. So here 1, 2, 3. Okay, don't count another double bond. Okay, 3 bond, automatically you need 3 orbitals, so you need sp2, 1s and 2p. Okay, 3. Now there are some partial questions, even though that they are not in your syllabus, but they have asked you before. I will just introduce this so that you can also learn more, because I didn't show it during the lecture. I don't want people to get confused. If, let's say, I ask you, predict what is going to be the type of hybridization that nitrogen will go through. Yeah, do remember nitrogen has, okay, 1 lone pair. Okay, how many types of orbitals are involved? Okay, you see, yeah, 1, 2, 3. But also involve this as 1 orbital because they are there. Okay, they are there. Okay, so this one is going to be, the nitrogen is going to be sp3 hybridized as well. Yeah, sp3 hybridized. If I put them together into this nitrogen is 7, yeah, so it's supposed to be 1s2, 2s2, 2p3. Okay, so if I put them, okay, like this, the electrons are here. Okay, and then the electrons are here. So when they say when hybridized, okay, it means this is what I said, the ground state yesterday. I forgot this term. Okay, ground state. This is the normal state. Okay, before getting married, people will get excited, but nitrogen, okay, they no need to get excited. Even though they become excited, they are ready to form bonds. Okay, with the hydrogen. How? They need 3 place for the hydrogen, right? They already have. Okay, they already have. So the ground state and the excited state is still the same. Okay. So what happens here? They do not need to actually bring this electron anywhere. It's okay already. Okay, so they just combine this orbital with all this. Okay, so sp3. So it means this one is this. Okay, so which is going to be the lone pair of the electron. Therefore, they are also sp3. So now some examples like amine. Okay, what will happen is going to be they will have this CH3, okay, amine like this, okay, and always remember, okay, even though, okay, nitrogen, carbon can form 4 bonds, nitrogen can form 3 bonds maximum, oxygen can form maximum of 2 bonds, okay, but if you have this, always remember, even though they don't give you this, okay, nitrogen will have a lone pair. Okay, now the last question, after this we can dismiss already. Even, can you tell me what is going to be the hybridization that this nitrogen underwent? And then someone will tell me what is the hybridization that this carbon underwent. Even try?
Not sure, sir.
Okay, same. Okay, you see, 1 bond, 2 bond, 3 bond, involve the lone pair. Okay, total you need 4 orbitals. So same, sp3. When they are in ammonia, when they are here, they are going to be sp3. What is going to be the hybridization of this carbon? So you see CH3, and then they are bonded to ammonia, NH2. Okay, so if I want to form for this only, very easy, 1, 2, 3, 4, sp3. Okay, this is what I want you to know. Okay, This is something, okay, sorry for taking your time, okay, your breakfast and so on, okay, but please remember all this, okay, very important. I will not take extra time, okay, when it is not required, okay, very important, okay. MCQ, they always test you on this, okay. Some of the question is easy, but because you do not know that, okay, that's why, okay, students tend up to take a lot of time. Yeah, that's all for today. Okay, I hope you learn a lot of things today. That's it for today. Okay, see you guys. Bye.
Bye, sir.
Yeah.
Bye, sir.
Bye, sir.
Bye, sir.